All right, we are on 5-2. This first problem will be the most difficult one for you. The first part's easy. It's just find the expected value. So you have a probability distribution. These probabilities right here add up to 1. And we're trying to find the expected value. So if we pick something at random, what could we expect the value of that to be? So to find the expected value, this is what that e of x represents. You're going to take the value of x, multiply it times its probability. I believe, and that is 5. I'm going to double check some of my math here. Yeah. Okay. So once you've got all of those values right there, you are going to add them up. So what have I got here? I got 5 and 6 is 11, and 9 is 20, 21, 23.5. 23.5. So let me give you an idea what that number means here. So let's just say all of these values were representing money. Okay. So let's say I'm playing the lottery, and 15% of the time I'm going to win 0. 25% of the time I'm going to win $10. 5% of the time I'm going to win $20, etc. Okay. So what I've just figured out is over time, if I play this over and over again, on average, I will come out winning $23 and 50 cents on every time I play. That's what my winnings would average out to be. I can expect to be winning on average. Now, the harder part of this problem, or not harder, but just it's going to be a little more tedious for you, is finding the variance. We haven't really talked about variance, but all variance is just standard deviation squared. So think of standard deviation. If you remember back when we were calculating this should look familiar. But what you're going to do, get rid of some of this, clear this up a little bit. What we're going to do here is we are going to take the x value, like this first one, and we're going to subtract what we just found, the expected value. So in our case, we'd say 0 minus 23.5. We're going to square that value, and then we're going to multiply it times the probability associated with it. So I'm going to do 0.15. All right, and I'm going to do that all the way down. I'm going to do that with 10 times its probability, which was 0.25. I'm going to do that with 20. And its probability 0.05. I'm going to do that all the way down to the last one, which would be 50. And multiply it times its probability 0.10. So I'm going to get all of those things, and then I'm just going to add them up. Okay, because this is what that summation symbol does. All right, I'm not actually going to calculate all that, but that's the process you would go through. Actually, I can ask me about showing you in class how to do all of this on your calculator with list. You could set these things in list and have this done for you relatively easily. But I can show you that in class. It's hard for me to do it on this software right here, though. All right, so that's really the harder problem. These other ones you'll fly through, I think. So the next one, what do we got here? Austin's in charge of planning a reception for 3,200 people. Okay, so 3,200 people. He's trying to decide which snacks to buy. He asks a random sample to see what he should get. Based on the above samples, predict the number of people at the reception whose favorite snack will be pretzels. Okay, so let's see. This is definitely, these numbers right here definitely don't add up to 3,200. Let's see what they do add up to. If I take 74 plus 36 plus 52 plus 63, they add up to 225. All right, so what Austin did was he asked 225 people to see what their favorite snack was. 36 of them said pretzels. So 36 out of 225 said they like pretzels the best. That is 16% of his sample. So you would expect, what he's going to think is, all right, well, I got 3,200 people coming. I'm going to expect about 16% of those to like pretzels as well, which would be about 512 people would be looking for some pretzels that day. That would be 16% of 3,200. There you go. That's how you're going to, that's how you're going to do that one. 512, sorry. All right, and lastly, it says Deshaun is playing a game of chance in which he rolls a number. A number cube with sides number 1 to 6 sounds like a die to me. The number cube is fair, so a side is rolled at random. The game is this. Deshaun rolls the number cube once, the die once. He wins $1 if 1 is rolled, $2 if 2 is rolled, $3 if 3 is rolled, $4 if 4 is rolled, but loses $2.75 when 5 or 6 is rolled. All right, so the question is, find the expected value of playing this game. So here, we got a probability he's going to roll a 1, a 2, a 3, a 4, a 5, or a 6. The probability of each of these is 1 out of 6. All right, and when he rolls a 1, he gets $1. When he rolls a 2, he gets $2. $3 here, $4 here. When he rolls a 5, it's minus $2.75. When he rolls a 6, it's minus $2.75. The question is, would you play this game? What do you think? Over time, are you gonna win money doing this? So let's find out. So what I'm gonna do to find out is I'm gonna do these multiplications here and see what my values are. I'm gonna do some rounding there. That's a decimal. Yep. 2.75 times. All right, so I just multiplied probabilities times the value that they could win on each one of those rolls. And now what I need to do is add all of this stuff up right here. All right, and see what I can expect. 0.17 plus 0.33 plus 0.5 plus 0.67 minus 46 cents and minus another 46 cents for a grand total of 75 cents. Oops. So that's a positive number. That's a positive 75 cents. So my expected value is 0.75. So it says, what can Deshaun expect in the long run after playing the game many times? Well, he can expect to gain money because he's got a positive number there, and he can expect to win 75 cents per roll over time. If this had been a negative value, I would have picked this one down here, that he would lose money. Okay, if I'd gotten 0, I would have picked this one here. All right, so that is those are the problems for 5-2. All right, good luck. Let me know if you need some help.